Level 1, the marketing fluff. Terms that mean absolutely nothing. Pure marketing language invented to make base models sound special or justify higher dealer prices. These words exist on glossy brochures and window stickers, never in engineering documents or factory specifications. Sport mode on economy cars is the biggest offender. That button in your Camry or Accord changes throttle mapping slightly and maybe holds gears a bit longer before upshifting. It does not add horsepower. Same engine, same transmission, just different software calibration that makes the car feel slightly more responsive. Marketing teams discovered they could slap sport on literally anything, and people would pay extra for it. Luxury package could mean genuine leather seats at one manufacturer and slightly better speakers with faux wood trim at another. There's no industry standard whatsoever. The definition changes by brand, by model, and sometimes by model year within the same car. Premium audio often just means more speakers scattered around the cabin, not necessarily better quality speakers. Premium interior might mean synthetic leather that the brochure carefully calls leatherette to avoid legal issues. Special edition and limited edition almost always mean different paint colors, unique badging, or special floor mats, rarely any actual mechanical changes worth paying extra for. Remember how many final edition Mitsubishi Evolutions supposedly existed. The touring trim originally meant a car specifically designed for comfortable long-distance highway driving. Now it means whatever the manufacturer decides it means that model year. A Honda Accord Touring and BMW 3 Series Touring are completely different vehicle concepts using identical marketing terminology. Level 1 terms exist to sell cars and empty your wallet, but Level 2, these terms actually mean something. They're just misunderstood by almost everyone, including many salespeople who should definitely know better. Level 2, the misunderstood basics. Terms everyone uses, but most people define incorrectly. These have real engineering definitions, but years of marketing misuse and casual conversation have confused everyone. Getting these right separates informed buyers from confused ones who get exploited at dealerships. AWD versus 4WD is the most widespread confusion in automotive. AWD means all wheels receive power automatically. The system constantly decides when and how much power goes where without driver input. 4WD means the driver manually selects engagement, and the system typically includes a transfer case with low range, gearing for serious off-road capability and rock crawling. Most crossover SUVs marketed aggressively as 4WD are actually AWD systems with no low range at all. A Subaru Outback's symmetrical AWD system is completely different from a Jeep Wrangler's true 4WD system with two-speed transfer case, even though dealers casually use the terms interchangeably to confuse buyers. Here's one that surprises almost everyone. Coupe versus sedan is not defined by door count. The SAE officially defines a coupe as having less than 33 cubic feet of rear interior volume. A Mercedes CLS with 4 full-size doors is technically a coupe because of its sloping roofline that reduces rear headroom and interior volume. Automatic transmission now actually covers 4 completely different technologies: traditional torque converter automatics, CVTs with no fixed gears using belts or chains, and dual-clutch transmissions like Porsche's PDK that are technically automated manuals with 2 clutch packs. Supercharger versus turbocharger. Both compress air into the engine, but superchargers are belt-driven with instant throttle response, while turbochargers use exhaust gases with slight lag but superior efficiency. Now you know the basics most people get wrong, but Level 3 is where it gets expensive. Badge letters that manufacturers charge thousands extra for. What do GT, RS, and SS actually mean? Some answers will genuinely surprise you. Level 3, the badge hierarchy. The letter and number combinations that appear on performance cars. Some have deep heritage and genuine meaning. Others are completely made-up marketing. Understanding the difference separates informed enthusiasts from people who pay thousands extra for a badge that means nothing. GT stands for Gran Turismo, Italian for Grand Touring. The original meaning described a comfortable, powerful C. Are designed for long-distance travel at high speed. The Ferrari 250 GT and Ford GT use this term correctly. A true GT car balances performance with comfort for eating miles on highways, but then Hyundai put GT on the Elantra hatchback, and Pontiac put it on economy cars. The term has been diluted to complete meaninglessness on anything that isn't actually a grand touring vehicle. RS means Rennsport, German for racing sport. On a Porsche, RS models are lightweight, track-focused weapons with stripped interiors and race-derived engineering. The 911 GT3 RS is a $230,000 track car. Audi RS models like the RS6 and RS7 represent their highest performance variants with genuine mechanical upgrades, but Chevrolet. The RS package on a Camaro is purely cosmetic: different wheels, black trim, maybe a spoiler, zero mechanical changes, same letters, wildly different meanings. Porsche RS could cost you $200,000 and destroy lap records. Chevrolet RS costs $2,000 and gets you a body kit. SS means super sport, originating from the 1961 Chevrolet Impala SS. At Chevy, SS still represents legitimate top-tier performance, bigger engines, better suspension, enhanced brakes. The Camaro SS is a genuine performance car. M comes from BMW's motorsport division. An M3 or M5 has a completely different engine, transmission, suspension, and brakes from the standard car. But here's where BMW gets sneaky. M Sport is just an appearance package with sportier bumpers and seats. It is not a real M car. Paying $5,000 for M Sport thinking you're getting M Performance is an expensive mistake. AMG stands for Aufrecht Melcher Grosses, the founders' names and hometown. Real AMG engines are hand-built by a single technician who signs a plaque on each engine, but Mercedes created tiers to confuse everyone. AMG line is pure appearance, fake vents, sportier styling, zero performance gains. The 43 AMG models use factory Mercedes engines with AMG tuning. Only the 63 and 65 AMG models get the hand-built engines that made AMG famous. That AMG badge might mean everything or absolutely nothing. Level 4 is where most car arguments happen: horsepower versus torque. Why does a diesel truck with 400 pound-feet feel faster than a sports car with 400 horsepower? The answer changes how you evaluate every car you ever consider. Level 4, the power numbers. Horsepower, torque, and the specifications people quote constantly without truly understanding what they mean. These numbers are the most discussed and most misunderstood in all of automotive. Level 4 explains what they actually represent and why comparing them incorrectly leads to completely wrong conclusions about how cars will feel. Horsepower is a rate of doing work, power over time. The mathematical formula is torque multiplied by RPM, then divided by 5,252. Horsepower determines your top speed and how fast you continue accelerating at high RPM. A 500 horsepower engine peaking at 8,000 RPM feels completely different from one peaking at 5,000 RPM. The first screams to redline and rewards aggressive driving. The second delivers power earlier and feels effortless. Same peak number on paper, but dramatically different real-world driving experiences. Torque is rotational force, the twisting power that gets you moving from a standstill, measured in pound-feet or Newton-meters. Torque determines how hard you get pushed back in your seat during initial acceleration and how easily the car responds from low speed. This is exactly why diesel trucks feel brutal and powerful off the line despite modest horsepower numbers. They make enormous torque at low RPM, where you actually use it for towing and hauling. This is also why electric cars feel impossibly fast despite their size. Electric motors produce maximum torque at 0 RPM, meaning full acceleration is available the instant you touch the throttle pedal. A Tesla Plaid makes 1,050 horsepower, but instant torque delivery is what makes it feel like a rocket ship launching. Here's a fact most enthusiasts don't know. Horsepower and torque numbers are always exactly equal at 5,252 RPM. Below that point, torque is higher. Above it, horsepower is higher. When comparing cars, always ask whether quoted horsepower is measured at the crankshaft or at the wheels. Manufacturers quote crank horsepower, but drivetrain losses mean 15–20% reduction for rear-wheel drive and 20–25% for all-wheel drive. A car rated at 300 HP might only put 250 HP to the actual wheels moving you forward. The most important number isn't horsepower or torque, it's power-to-weight ratio. A Miata with 180 HP feels faster than an SUV with 300 HP because it weighs half as much. Lotus built their philosophy around this, adding lightness beats adding power. Now you understand power. Level 5 is engine terminology, displacement, compression, forced induction. Why does a 2L turbo beat a 3.5L V6? Why do some engines last 300,000 miles while others explode at 60,000? The answers are hiding in specifications you've been ignoring. Level 5, the engine specifications. The technical numbers on engine spec sheets that most buyers skip. These determine reliability, performance, fuel requirements, and how an engine feels. Understanding them separates casual enthusiasts from people who read engines like books. Displacement is total cylinder volume combined, measured in liters or cubic centimeters. A 2-liter engine has 2,000 cc swept by the pistons. Larger displacement traditionally meant more power, but modern turbocharging changed everything. A 2-liter turbo can match a 4-liter naturally aspirated engine because forced induction crams more air into smaller cylinders. The saying, "no replacement for displacement," is outdated. Turbochargers became the replacement. Compression ratio describes how much the air-fuel mixture gets squeezed before spark ignition. A 10:1 ratio means the mixture compresses to 1/10 its original volume. Higher compression extracts more usable energy from each combustion event, more efficiency and more power per unit of fuel burned. But higher compression absolutely requires higher octane fuel to prevent premature detonation that damages internal components. This is exactly why some cars require premium fuel. It's not a suggestion or a luxury. The engine will knock and potentially suffer expensive damage running regular fuel. Mazda's Sky Active engines achieve an impressive 13:1 compression ratio while running regular fuel through clever engineering. Bore and stroke explain engine character better than almost any other specification. Bore is cylinder diameter. Stroke is the distance the piston travels. Over square engines with bore larger than stroke rev high and love RPM. The Honda S2000 screams to 9,000 RPM specifically because of its short stroke design. Under square engines make torque at lower RPM, perfect for trucks needing pulling power. DOHC, SOHC, and OHV describe valve arrangements. OHV uses pushrods in the classic American V8 design. SOHC runs one camshaft per head. DOHC uses two camshafts, allowing better valve control and variable timing. Naturally aspirated engines breathe without forced air, increasingly rare as emissions regulations push manufacturers toward turbos. Turbocharged engines use exhaust gases to spin a compressor. Supercharged engines use belt-driven compressors for instant throttle response. Level 6 is where driving becomes science, chassis and handling terminology. Understeer, oversteer, weight transfer. The difference between a driver who reacts and one who predicts. Level 6, the chassis and handling terms. The vocabulary of vehicle dynamics, how cars turn, brake, and transfer weight. This terminology is used by racing drivers, chassis engineers, and serious enthusiasts. Understanding it transforms how you feel and control any vehicle. Understeer happens when front tires lose grip first. You turn the wheel, but the car pushes wide instead of following your line. Oversteer happens when rear tires lose grip first. The back slides out and the car rotates more than intended. Uncorrected oversteer becomes a spin. Most road cars are designed with understeer because it's safer. When you exceed limits, the car goes wide rather than spinning. Rear-wheel drive sports cars can be tuned for adjustable oversteer, which is why drifting exists. Weight transfer is the absolute foundation of all car control. When you brake, weight shifts forward, front tires gain grip while rear tires lose it. When you accelerate, weight shifts rearward, rear tires grip more, fronts less. When you corner, weight transfers to the outside, outside tires grip more, inside tires less. Every single input instantly changes the grip balance of all four tires. This explains trail braking. Maintaining brake pressure into corners keeps weight on front tires for better turn-in grip. It explains why powerful RWD cars spin mid-corner when you floor it. You've suddenly unloaded the rear tires while asking them to handle acceleration and cornering simultaneously. Slip angle explains why racing drivers appear to constantly slide their cars. It's the angle between where a tire points and where it actually travels. All tires generate maximum grip at some slip angle, typically between 6 and 10 degrees. Below that angle, you're not using the tire's full potential. Above it, the tire slides and loses grip. Professional drivers operate right at peak slip angle, which looks like controlled sliding, but is actually maximum mechanical grip extraction. Polar moment of inertia explains why mid-engine cars feel so different. It measures resistance to rotation based on weight distribution. Mid-engine cars concentrate mass near center. Low polar moment means quick, eager direction changes. Front-engine cars with rear trunks have weight at extremes. High polar moment means resistance to rotation, feeling sluggish. This is why a Porsche Cayman feels more agile than the 911 despite less power. Level 7 is terminology that protects your investment, engineering knowledge separating buyers from those who truly understand machines. Level 7, the engineering deep cuts. Terminology from engineering documents, technical service bulletins, and enthusiast forums, rarely found in marketing materials or dealer brochures. This knowledge protects your money, explains why certain cars fail catastrophically while others last forever, and represents true automotive literacy. Timing chains and belts synchronize crankshaft to camshafts, ensuring valves open at the right moment. Belts are rubber, need replacement every 60–100 miles. Chains last longer but can stretch and fail. Here's what manufacturers hide. Most modern engines are interference designs. Pistons and valves occupy the same space at different times. If timing fails, pistons slam into valves. Catastrophic destruction, bent valves, broken pistons, cracked block. $200 belt replacement, ignored becomes $8,000 engine replacement. When manufacturers claim lifetime chains, they mean warranty lifetime. BMW's N63 had notorious chain failures just outside warranty. Monocoque versus body-on-frame determines how vehicles handle damage and modifications. Monocoque, also called unibody, means body panels are structural. The entire shell is the frame integrated together. It's lighter, stiffer, and handles better. Nearly all modern cars use this design. Body-on-frame separates the body from a ladder frame underneath. It's heavier but significantly stronger for towing, and damage is easier to repair. Trucks and serious SUVs use body-on-frame. You cannot lift a unibody like a truck. Cutting structure compromises chassis integrity. This is why frame damage often totals unibody cars but not trucks. Limited slip differentials solve open differential problems. Open diffs send power to the wheel with least resistance. If one loses traction, all power goes to the spinning wheel while the gripping tire gets nothing. LSDs limit speed difference between wheels, ensuring power reaches both even with unequal traction. Performance cars need LSDs. Accelerating out of corners requires power to both wheels, not just the unloaded inside tire. Direct injection sprays fuel directly into cylinders at high pressure, more power and efficiency, but carbon buildup on intake valves since fuel never washes over them. Port injection sprays into the manifold, keeping valves clean. Toyota now uses both systems simultaneously for best results.
OBD2 codes.
Your diagnostic window into the car's brain. Since 1996, every car uses standardized codes. A check engine light is a specific code readable with a $20 scanner. P codes are powertrain, B codes body, C codes chassis. Knowing codes before visiting mechanics gives you negotiating power and prevents unnecessary repairs.